Hello everyone, welcome back. In this video you will learn how to run descriptive statistics and also how to interpret the results in SPSS. Please note that descriptive statistics is used for continuous data such as height, weight, age and others. But before we move on, let me quickly take you through some basic things that you need to know about descriptive statistics. First, what exactly are descriptive statistics? Descriptive statistics are simply the summary that describes the basic features, the behavior, or the attributes of your data, and these statistics include the mean, the median, the mode, standard deviation, observations, scale, kurtosis, and others like that. So all these statistics provide a clear view of the features of your data. Also, these statistics helps you to understand your data before running more advanced analysis. As a matter of fact, they also dictate the method of analysis that is suitable for your data. For instance, if you notice that your data is not normally distributed from skewness and kurtosis results, then you must ensure that you use the techniques of analysis that accommodates that particular issue. Now, how to interpret descriptive statistics outputs. There are some statistics that will automatically appear when you run your descriptive statistics in SPSS, and the first is mean, which is also known as the average, and the mean is simply the arithmetic average. It gives the central tendency where most value cluster around. So the means will give you a quick idea of the average of all your data. For instance, if the mean age is 27 or 27.5, then on average you can simply say that the participants in that particular survey are about 27 years old. And if the mean is around 30, then you should know that the participants on average are around 30 years old. The next statistics which you will certainly see when you run your descriptive analysis is median, which shows the middle value. The next is standard deviation, and standard deviation simply tells you how spread out the value are around the mean. For instance, if the mean age is 27.45, then the standard deviation will give you a value that shows how your data spread around 27.5. I want you to quickly take note of this, that a small standard deviation means that the data points are close to the mean. For instance, if the standard deviation of an exam score is 2.5, then you can simply say that most students scored within 2.5 points above or below the average score. But if the standard deviation is maybe 10, in that case it simply means that the most students scored within that particular point, 10 above or below. So now a large standard deviation simply tells you that there is a wider spread, and it shows that the data is more volatile, or it varies. The next thing you will see is minimum, and followed by that is the maximum. What does minimum connote? It simply shows the lowest value in your data. For instance, if you have a data that ranges from 2 to 10, then the minimum is 2, so you will see 2. Then if you have several variables, then you can compare the minimum across the variable, while the maximum also, it indicates the highest value in your data. So please take note of that. For instance, if you are running descriptive statistics for energy prices, for instance, we have different measures of energy prices. You can use Brent, you can use WTI, and you can use refined. So now if you run the descriptive statistics, you will know the minimum, and the minimum may not be the same. Of course, you may have a similar minimum, but maybe by points there may be little difference. So now from there you can simply say that, okay, out of the 3 variables, so as the minimum price, why this as the max. The next question you may want to ask is, why is descriptive analysis matters? The first reason why it matters is because it helps researchers or analysts to quickly spot outliers or check the data range. For instance, if you have the minimum and the maximum now, then you can quickly determine the range. Also, it helps to determine if there is an extreme any value, if there's a value that behaves abnormally in your data set. See this example. If someone has an income of $0 or at least a test score of 100 when everyone else is around 50, you might want to investigate that. So that's simply an outlier. For instance, out of 200 students, and you notice that only one person scores 0 while all others scored around the average, then you may want to ask, why is this person's situation different? So when you do your descriptive analysis, you will quickly know that because the minimum will show 0, so you will know from there that okay, one of the students scored 0. Then you can probe further, or you can investigate why such. Maybe it was an error, or if it is real, then you need to go through your procedures and check. Okay, this is skewness and kurtosis. Skewness tests us whether the data is symmetrical or leaning more to one side. Please take notes of the following. A skewness of 0 means a perfectly symmetrical or normal distribution. When the value of skewness is 0, it simply tells you, or is around 0, maybe 0.2, 0.1, it tells you that it is normally distributed, and that simply means that data has a bell shape. A positive skewness means the tail is longer on the right, more lower value, and a few higher ones. So that means data is rightly skewed. While a negative skewness means that the table is longer on the left, more highly valued, more high values, and a few lower outliers. So that means the variable is left skewed. But there are some rules that you need to take notes of. For instance, if you want to, before you can say your data is symmetric, fairly symmetrical, or moderately skewed, then you need to take notes of this. If the value of the skewness is 0, you can say it is symmetric, perfectly symmetrical, or it is normally distributed. But if it is between 0 minus 0.5 and plus 0.5, then you can say it is fairly symmetric, that is near normality. Next is if the value is between minus 1 and 0 and minus 0.5 or plus 0.5 and plus 1, then it is moderately skewed. But the worst case is when it is highly skewed, that is when the value is beyond plus or minus 1. So you should take notes of this rule of thumb because it will certainly help in your discussion. The next one is kurtosis. Kurtosis tells how peak or flat the distribution is compared to a normal distribution. So we have different one. We have a positive kurtosis, a negative one, and also for this case we have rule of thumb. For instance, if the value is 0, that simply means that it is normal. It is the data is normally distributed. But if it is a positive kurtosis, which we reverse to as leptokurtic, it simply means that this distribution is tall and skinny, and in that case we can say that the data are tightly clustered. And the last issue, the last thing which you may also come across, is a situation whereby you have a negative kurtosis, and which is reversed to as platykurtic. In that case, you can simply say that the distribution is flat and wide, and it shows that there are more dispersed value. In this case, you may have a larger standard deviation because the data spread. But before you can conclude whether this is an issue or not, you need to master the rule of thumb as well. In a situation whereby the kurtosis is 0, for instance, if you run SPSS, you may have a 0, and for other software, it may give you 3 or between minus 1 and plus 1. In that case, you may say that the data is normally distributed. There is no problem of normality. When the kurtosis is both 0, 3 or plus 1, it simply means that the distribution has heavier tail and a sharper peak. So both peaked and flat, they are issues. The only one that is not an issue is mesokurtic. So when the value is below 0, 3 or minus 1, that means there is a problem with that data, and it indicates a distribution with a lighter tail and a flatter peak. So that's what we reverse to as platykurtic. So you need to take note of the rule of thumb, rules rules of thumb, the mesocortic, the leptocortic, and the platocortic. So when you are also interpreting your results, if you are not limited by what counts, you can mention all these things so that your supervisor or the readers will understand that you have a clear idea of what you are saying. Now, the question you may want to ask is, how can we address a situation whereby we have a platocortic, leptocortic, or a situation whereby the distribution is not normally distributed or the data is not normally distributed? If skewness or kurtosis is significantly above or below 0, especially outside plus or 2 for smaller sum, your data may not be normally distributed, and this could have an effect on your statistical test. So what you need to do when you have issue of non-normally distribution is, one, you can use a non-parametric test. For instance, if you notice that your data is not normally distributed, then you can use a contour regression analysis. And for primary data analysis too, there are techniques that do not require that your data should be normally distributed. So you just look out for those techniques and you make use of it. Another thing that you can do is to transform your data. If you have a continuous data, then you can just convert it to, maybe you can take the log of your data, and if it's also appropriate, you can square your data. But the one that is very common is to take the natural log. So when you transform your data and you do the analysis again, you may have a very result. So those are the things that you need to know about descriptive statistics. First, your mean. You must know what it stands for and how to interpret it, your median. Next, you must also know how to interpret minimum and maximum, skewness, kurtosis, and the last one, which is not here, is observation. So now let me show you how to do this analysis in SPSS. This is the data worksheet I want to use. If you look at this, we are currently in data field. We have height, we have weight. These two variables are continuous data. Also, we have income, which is also a continuous data. Here we have a square. This is square of income. This is the natural log of income. Basically, okay, we have weight before and weight after. All these ones too, they are continuous data, and we can make use of descriptive analysis for them. Now, to do your descriptive analysis in SPSS, the first thing you need to do is to go to analyze. You click on analyze, then here you see descriptive statistics. So you select descriptive statistics. In the previous video, I selected frequency, but in this case, you have to select descriptives. So once you click on it once, this window will open, which is very similar to that of it's even the same. The only thing, the options here are different from the other one. So now you need to look for continuous data. We have height, we have weight, also current salary. Let's make use of those three variables. Then you click on this to move the data here. Once you move it here, you can click on option in case you want to add or exclude any statistics. Here is mean. Sum is not selected, and we don't need it, so we are not going to select it. You may want to select range. That is the difference between the minimum and the max. You may want to select that. Variance, we don't need this. We have standard deviation already. Kurtosis and skewness, this is for distribution. If you want to report it in your analysis, you can just select it. But if you are not interested in the normality, but the point is that you must be interested in the normality, because you cannot just pick any techniques to analyze your data. The techniques of analysis will be dictated by the distribution of your data as well as the unit root test, the result of your unit root test. So in this case, we are going to select kurtosis and skewness. Every other thing here will remain the same. So once you are done with this selection, the next thing is just to click continue, and you have it here. If you want to make use of Bootstrap, you can do this. But in this particular tutorial, we are not going to touch these two options. So the next thing now is to, in case you want to save the standardized value, you can select this, but we are not interested in that. So the next thing is just to click OK, then you have your results. Now we have our descriptive statistics. How many variables do we have here? We have 3 variables. The first one is height, the second one is weight, third is current salary. Then we have several statistics. The first one is N, which is observations, the one I did not include in the PowerPoint presentation. N is the observation, and you can see here we have 20 observations. Here is the range, which is the difference between the minimum and the maximum. If you look at it very well, if you subtract 40 from 90, 98, you will have 58. And this is, if you subtract this from this, you have this. You subtract this from this too, you have this. Then we have the mean, which is the average value. Then we have the standard deviation, which shows how variable, how the data varies, or the spread of your data from the mean. Next, we have skewness. We have the standard error, the statistics and standard error, and also we have the kurtosis. We have the statistics and the standard error. Take note, we have three variables here: height, weight, and current salary. So for height now, the first row here, all the values here are for height, the next for weight, and the third for current salary. So that is how to run descriptive statistics in SPSS. Please, if you have any other question, you can just post your question in the comment section. Thank you and God bless.